Hi, I'm Alec, and today I'm going to show you 3 ways of using Firestore to build data-driven UIs and eliminate state in your Flutter applications. I've been developing apps for 10 years for huge international brands like McDonald's, as well as startup MVPs and everything in between. I'm the CTO and co-founder of Done, where we have been using Flutter since 1.0, and in this series, I want to show you tips and tricks from real-life applications that you can use to build better apps. Firestore is a great choice for powering your mobile application with data. My favorite aspect is its real-time nature, which enables you to think about data and communication flow in your app in a completely different way. And many times we can actually use it to eliminate local state from your app completely, and thus avoiding the age-long discussion of which state management framework to use in your app. Throughout this demo, you're not going to see any set state or providers, river pods, blocks, but rather just a simple unidirectional data flow provided by Firestore. And in all of the examples in here, we use a stream builder to either listen to documents or collections and let Firestore handle that state for us. We just listen to the stream and display what's going on in the UI. So this first example might seem a little bit trivial, it's chat, but it's an example of listening to a collection of documents. So in here, you can see we have a chat message list and a text composer. And whenever we submit through the text composer, we just add a new chat message to the messages collection. And in the list, the only thing we really do is to fetch that collection of chat messages and display them. So we have a list view, we show all the messages in reverse because we want the latest to be at the bottom, and we build chat items. So this is super simple, right? We write a message, hi, we send it, and a new document is created. And vice versa, if we create a document ourselves here and save, it shows up straight into our chat. This may look super simple, but we're doing with real-time data here from a database and back to our app, and it's collaborative, multi-user, works like a charm. Okay, so this was pretty simple. Now let's look at a more interesting example. In this case, let's imagine that we want to build some kind of reactive UI which reacts to external state. It might be like a bank signing application or payment application where our app does something, initiates a payment, but then we have other systems calling back and we want to show to the user what's going on with their payment process, even though there might be other apps and other systems involved. If you wanted to create this kind of UI with traditional REST APIs or GraphQL APIs, you would probably have to tell your backend engineers, please can I get a socket API? And then having to resort to polling. Both these options require you to keep local state in your application. But with Firestore, we can avoid all of that. And instead, I'm going to show you a technique where you just listen to a single document with a state change update. And that way you can sync your app's UI to whatever is happening on the backend. So here we got our bank UI. As you can see, when you go in, there is a button to pay. So we press pay and we have a loading. Now what happens on the server side could be a multiple different things. It can be your payment processor waiting for something. So during this time, we're listening to this BankID sessions document. And now you can see it has a state loading. And if we change the state to waiting for BankID, for instance, it shows a different UI. Now we might have to prompt the user to open another app to identify themselves. And that app might in turn call to our backend with a callback. And as soon as we change the status to finished, we can see that our UI is updating and it says the payment is complete. If something happens on the backend, we can at any time let our UI and our app reflect what's going on. If there's an error, we show an error, we can try again from the app, etc. It becomes really easy for both our app and the backend services to kind of manage this complex UI flow with multiple parties involved. So how is this implemented? Well, just like in the last example, it's super simple, and the only thing we do is just listen through a stream builder for a single document. So we here got our BankID page. And as you can see, we have a stream builder in the center, which just listens to our BankID sessions document. And depending on which statuses we get, we show a different widget. Of course, you can add more properties here to convey even more information. Super simple, but really, really powerful. Now for this last example, I want to show you a really cool trick for a pretty complex use. And this traditionally requires a lot of local state in your application, which we will avoid completely with the help of Firestore. So sometimes in your application, you have objects that you want your user to edit, but which has multiple fields. Any edits you want to keep atomic, meaning that if the user just changes the title here, we don't want to save that directly because they might want to change the title and the date of this event simultaneously and have that as a single atomic change before it's broadcasted out to other users. With a traditional API, you would probably make a copy of the entire document locally, and you would modify your own local state before the user presses save or cancel, at which point you then update the remote state on the server. The problem with this approach is that since it requires you to keep local state in your app, either you need to have mutable models or you need to do models which supports copy width. Of course, you can do that with freeze, but it requires a lot of code and it requires juggling of state. And this is why there are so many state management frameworks out there to help us out with this complex problem. But this trick I want to show you eliminates all of that. So instead, what we're going to do is create a working copy. So whenever the user starts the edit of the document, we create a new copy of that document in Firestore. And while the user is editing, they can edit that working copy, and as soon as they are done, we save that working copy, overwriting the real document and throwing the working copy away. Let me show how it's done. So the user presses this Firebase Summit event, and as you can see here in Firestore, a working copy of that document is immediately created with the same field as the original document. Now when we change the title here, it only updates the working copy, and we can change both at the same time. And both of these fields are changed, but the original document stays the same. And now, whenever we press save, we replace the data in the real document and delete our working copy. And this is how we implemented this. If we take a look at the event item list tile here, you can see that on tap we run this edit event method. In Firestore, you can actually create sub-collections inside of documents, and that's what we're going to use right now. So when the user taps on an event, first we create that working copy inside of Firestore. We create it in a sub-collection of this event, and we just dump in all of the data of the original document. Next up, we push our editor page and provide it with a reference to our working copy. Looking at our editor, this is a stateless widget, and even the entire form is stateless. So here we use the same stream builder trick as earlier. We listen to our working copy event reference, and whenever we have data, we show the event form. And this event form just contains two fields, and whenever one of the fields are submitted, we update the document reference, which we know actually points not to the event itself, but to the working copy. By doing this, we don't need to have a local in-memory copy of the event here inside a widget, but rather we keep that state on Firestore. The benefits are not only that we get simpler state inside of our app, but also in case something would happen with the user's phone mid-edit, like they need to get on the bus and they jump into a different app, and our app gets killed in the background, we still have a saved copy of the edits in the cloud at Firestore and can easily recover it once we start up the app again. So when the user saves, we just pop and return true from the route. Okay, now we got the result back from the event editor. Once this await completes, we know if the user saved or cancelled. if the user saved, we need to update the original event. And how do we do that? Well, we just take the data from the working copy and replace the original document with that data. Finally, we need to clean up after ourselves, so we delete the working copy, regardless if we did a save or a cancel. So those were my 3 tips of how to use Firestore to eliminate local state in your app. Now, if you want to check out the code, it's all on GitHub. Do you have any creative uses of Firestore in your app, or a question about how to remove local state? Post a comment below. Thank you for watching my first YouTube video, and since I'm not a full-time YouTuber, I won't be uploading videos that often, so please like and subscribe if you want to see more content like this. Bye bye!